Hello, my name is Muhammad Firdaus bin Zulkifli. My DTP number is 10 DTP 20F 2012. And then is my friend Iman and Alif.
Hello and greetings. Thanks for Muhammad Firdaus for starting our presentation, and I will introduce our group mate, which is me as a group leader, Muhammad Iman Hazim Hakim, and my meeting number is 10DP21F1042, and also following by Muhammad Alif bin Azhar, which is his metric number is 10DTP21F12002, and also lastly Muhammad Firdaus bin Zulkifli, which is his metric number is 10DTP21F2012. And hi, so I will explain about the goals. Our first goal is to explain what is vector and scalar, and also to explain the application of vector and scalar. The second one, our goals is to solve or to solving an example for much better vision on how to apply the vector and scalar method. And also our third goals is showing the real life application to represent the function of using vector and scalar in daily life. So I will proceed for our introduction in vector and scalar.
Vector and scalar. What is vector? Vector in physics, a quantity that has both magnitude and direction. It is by typically represented by an arrow whose direction is the same as the of the quantity and whose length is proportional to the quantity magnitude. What is scalar? Scalar, a physical quantity that is completely described by its magnitude. Explain of scalar: a volume, density, speed, energy, mass, and time.
Greeting to my lecturer and my fellow friend. My name is Muhammad Alif bin Azhar, and I'm from DBM10013. Today I would like to do a presentation about vector and scalar comparison. As you can see on your screen right now, there are the table of differences about scalar quantity and vector quantity. Okay, the first difference is scalar quantity has only magnitude but no direction, while vector quantity has both magnitude and direction. Okay, the second point is every scalar quantity is one-dimensional, while vector quantity can be 1, 2, or 3-dimensional. Okay, the third is scalar quantity cannot be resolved as it has exactly same value regardless one direction, while vector quantity can be resolved in any direction using the sine or cosine project of adjacent angle. Okay, the fourth is any mathematical operation carried out among two or more scalar quantities will provide a scalar only. Okay, however, if a scalar is operated with a vector, then the result will be a vector. Okay, while result of mathematical operation between two or more vector may give either scalar or vector. For example, dot product of two vector give only scalar, while cross product of summation or subtraction between two vector result in a vector. Okay, for example of scalar quantity is length, mass, energy, density, and temperature. Okay, while the example for vector quantity is displacement, velocity, acceleration, weight, and force. I would like to give you a vector and scalar application example. Okay, first is force, torque, and velocity. The second is military usage, and the third point is projectile, and in gaming, also in roller coaster design.
Assalamualaikum warahmatullahi wabarakatuh, and greetings to my fellow friends and my lovely lecturer, which is Encik Muhammad Syukur. Today I am going to present about real life application using the vector and scalar method, which is how we can apply the vector and scalar in our real life situation. First, I'm going to introduce myself. I am Muhammad Iman Hazir Hakim and my magic number is 10DP21F1042. Without wasting so much time, I'm going to proceed with my questions. So moving on to the questions, which is we have a diagram that shows Ramli's house, a bank and also a stadium. The question is, Ramli wants to go to the stadium to watch Malaysian football match, but the shortcut route to the stadium was flooded, which is P to Q is flooded, so Ramli can go through there. Because of the heavy rain that happened lately, Ramli had to go through a long way to reach the stadium, which is Ramli needs to go to the bank, and from bank he can go to the stadium, which is shown that Ramli needs to go to P to R and R to Q to go to the stadium. The question is, what the angle between PQ and PR row? So we're given information which is P to Q is 6i and also R to Q is 5j. But moving on to the solution of the questions, which is the first we need to find the vector of PQ, and we have given the information that P to Q is 6 km and also R to Q is 5 km, which is we can find the unknown value of P to R is PQ plus RQ, which is 6 km plus 5 km equals to 11 km. So next we need to find the magnitude of vector PQ and PR, which is the determinant of PQ equals to the determinant of PQ equals to power source 6 power of 2 plus 0 power of 2 equals to power source 3/6, and we get 6 for determinant PQ. So next we have to find the determinant of PR, which is equals to power source 6 power of 2 plus 5 power of 2, and we get power source 36 plus 25, and we get power source 61, and we solve it, that we get 7.81 kilometers for determinant PR. And lastly, we need to find the angle between PQ and PR, which is we need to use the scalar dot. And the equation for scalar dot is PQ dot PR is 6 multiply 6 plus 0 multiply 5, and we get 36 plus 0, and for PQ dot PR we get 36. So we need to include the information that we have find, which is the determinant of PQ and determinant of PR, which is 6 multiply 7.81 kilometers, and we get 46.86 kilometers. So that we can continue with cos theta equals to PQ divided by determinant PQ and also dot PR determinant by divided by determinant PR, so that we get cos theta is equals to 36 divided by 46.86, and we get cos theta equals to 0.77, and we move the cos to the right equation, so we get theta equals to cos -1 multiply with 0.77, and we get the angle. The final question, the final answer is 39.65 degree. That's the answer for the angle of between PQ and PR. The conclusion of this question is that Ramli has to use the shorter road, that PR plus RQ road. So Ramli's car did not broken because of the flood and save more time. So that's all from us. The real life application for vector presentation 2, engineering math 1. Any question you can ask to us informally. Thank you very much.